So in this video tutorial, we'll learn about the Apache Sqoop. So we'll go through one by one. Please watch the video till end so that you can learn the basics of Sqoop very well through this video. So first we'll learn the need of Apache Sqoop. Why the Apache Sqoop is coming to the picture. So the need of transfer of the data between the traditional RDBMS and HDFS is very important. First, you should supposed to know this thing. That is, before HDFS and Hadoop came into the picture, the world's data were stored into RDBMS. Now, we need to smoothly transfer the data between these RDBMS software repositories to the HDFS. Yes, the work of Hadoop starts after the data is loaded to the HDFS now. So we should supposed to take the world's data which is in the RDBMS software to first into the HDFS repository. Then only we can start working. Yes, so this is a very tedious work. In writing a MapReduce code to convert and make a connection with the traditional RDBMS data and to transfer it to the HDFS. You know that HDFS is the storage part of Hadoop. It's a very tedious work to convert and change and transform and to load the data from RDBMS to HDFS through MapReduce coding. So we need something special. We need something simple and effective which can make our requirement full. The requirement of taking the data from the RDBMS to the HDFS. So that's the need and focus and the requirement why we need Sqoop. Why this Sqoop came into the picture actually. So Sqoop provides what? It provides one command based interface. Yes, CLI, command language interface, command level interface. It provides the command level interface will make you sure that you write a specific line of code, and when and the code is not a code actually, it's based on the command. So when you write down the command and press enter, it makes sure that the command will execute and the data from the RDBMS will be loaded to the HDFS and the vice versa. That is, HDFS data can be exported back to the RDBMS. So that's what this entire very useful tool of Sqoop is designed by Apache. And the Sqoop, the commands, each and every Sqoop commands internally will be converted to the MapReduce code. That is, for each command it will be converted to map processes, because a reduce process, that MapReduce is made up of map and reduce, right? But the reduce part is not required over here because reduce part does the aggregations, correct? We don't need over here the aggregations. We just need to load the data. So for that particular purpose, we don't need the reduce functions. So only each and every Sqoop commands will be converted to the map process of the MapReduce internally. So what's the advantage of that we'll get of all these things? First, we'll get the simplicity, because Sqoop is very simple. It's a command based, few commands we have. We should supposed to know those commands. Then we can export and import the data from the HDFS and to the HDFS. And it's based on the Yarn architecture, yet another resource negotiator. You know that Hadoop 2 onwards, Yarn architecture has been introduced, and the Hadoop 2 onwards the MapReduce and the HDFS runs on top of the Yarn only. And as it is run on top of the Yarn, it is possible to provide parallelism. And as we can distribute the job through parallelism among the many map processes, we can get the speed of it. That is, the data can be parallelly we can load from one particular RDBMS to HDFS, and it also provides the fault tolerance through replication factors. The property of Yarn. So all these things it provides. So that's the need of Sqoop in single term. So the same thing we are just providing over here with a pictorial depiction with this particular picture as there in front of you. You can see that what's the problem with RDBMS. So this RDBMS, it has it's very tedious process to import the data from RDBMS to HDFS. And the problem with the RDBMS is that it's difficult to handle large data sets. The real world data are the big data, right? So the big data, even if it can be stored in RDBMS, it cannot be processed. So to process the data, to analyze the data, we should supposed to provide it to the HDFS, and for that we require to be transformed for the RDBMS to HDFS. So that's the one, that's the use of Sqoop. So there is another problem with RDBMS. It cannot store unstructured data, and the time consuming task, it cannot be executed on top of the RDBMS, because RDBMS is very slow, because it cannot provide incremental and robust incremental storage modifications, because the data in RDBMS is it can be increased horizontally. That is, you cannot increase the capacity of your processor and your hard disk after a certain point of time. But as a solution, we have Hadoop over there, which can provide vertical and keep on adding the new hardwares and software in terms of different nodes, and the time it consumes to process a certain job in terms of with respect to the RDBMS is very less. Yes, so this is why we need is the processing huge volume of data. Will need loading data from diverse different sources into Hadoop cluster. Yes, so the heterogeneous sources are there available. The heterogeneous sources will be having their own repositories. We have to get the data from those sources, and there are many challenges we have when we load the data from the different sources. That is, one is that maintaining the data consistency. That's a big problem. The data consistency is a very big problem, because suppose the RDBMS data is there, the data has been loaded somehow, but suppose the RDBMS data is now modified. Suppose new employees, there is an employee table in RDBMS. You have taken the data of the employee table. Now the new employees has been joined and their data has been increased. The data has been added to the RDBMS. Now again you have to pull it back from the RDBMS to HDFS. So that to maintain data consistency will be a big problem. Yes, ensuring that the efficient utilization of resources is also a very big deal. Loading bulk data to Hadoop was not possible. So all these things are challenges which are recovered by Sqoop. Loading the data using scripts was slow. If you use a script based programming language like Pig and a similar kind of programming language, and suppose you are just loading the data from the RDBMS to HDFS, then it will be very difficult for you, in terms that Pig and similar kind of script based programming languages are always slow than the command based languages. If you use the command, it will be definitely executing fast. Sqoop is command based. So we'll go through the definition and the definition of Sqoop now. We'll see what Sqoop provides. So the first thing you should supposed to know about the Sqoop is that it is provided by Apache and it is open source. You will get it free. Then the requirement of it. What's the need and requirement of Sqoop? What is the solution it provides? Is that it transfers the data between RDBMS and Hadoop. Yes, these things are explained, so I'm just going first. How the name has come, Sqoop, S-Q-O-O-P. See this in the right hand side? I have provided here, see? So here is provided. SQL plus Hadoop. First two letters of SQL, that is SQ has been taken, and last three words of Hadoop, that is OOP, has been taken. So Sqoop is made in this way. So that is the name we have here. Now it has the abstraction over MapReduce. That is each and every, it's a command line interface application also. Command line interface application means we can write down each and every aspect of data transfer between the RDBMS and HDFS, that is import and export of data between the RDBMS and HDFS using command line interface, only by using commands. And these commands will be now will be transferring the data between the RDBMS and Hadoop, and all these commands will be internally converted to the MapReduce code. Yes, so it's an abstraction over MapReduce also, and data can be loaded not only to the HDFS. We can use Sqoop to load the data directly to Hive and HBase also. If you don't know what is Hive and HBase, I hope that you know. If you want to have a revision, or if you just want to go through with that, you can see my videos on Hive and HBase. So what you can see that in a pictorial depiction, we had gone through with that. We have shown over here that we have the RDBMS. That there are different softwares for RDBMS like MySQL, Oracle, MS SQL, DB2, and all these softwares are there. They store RDBMS data. What is the RDBMS data? It's a table. It's a structured table. Each table has column names. Based on the column names, we store the data in terms of the rows. Correct na? So from this RDBMS we store the data. How? Through Sqoop. Using the Sqoop MapReduce we load and unload the data. Yes, we can load to the HDFS, or you can load to the Hive, or you can load to the HBase. Here we'll focus mostly on HDFS. How this Sqoop tool is used for using this connection, we use different Sqoop options and commands. We use Sqoop commands, and along with that we use different options to specify the destination URL and what type of IP address you are using, what is the IP address of the RDBMS software, where is it installed, what is the directory in HDFS. Each and everything we can specify by using different Sqoop commands and their parameters, their options, and how we'll communicate between different RDBMS and HDFS or Hive or HBase by using different drivers we have. We have the MySQL connections, we have the Hive warehouse directory, we have HBase location, HDFS location, etc. parameters we have. And internally Sqoop is works based on JDBC, Java Database Connectivity. Those things will come later. So this is what basically Sqoop is and how it works basically. Now we'll go through with the features of Sqoop. What are the features we have? We'll go it fast. First of all, it's robust. Apache Sqoop is robust. It has the community support, means there are a lot of the people in the world who are using RDBMS and HDFS to transfer the data between them, and they are using what? HDFS. They're using Sqoop. So they have community, online community, so you'll get the support. If you have some issues, if you have some problem and something you are stuck into, then you can get the support from the community. You can just post your queries and you can have a video or chatting or audio call up and get the solution done. Yes, and it has community support and contribution and is easily usable also. That's the benefit of Sqoop as well, not only features. Now we have the full load option. The whole full load means full table loading by a single command. You'll write down a single command of Sqoop and it will load the entire table from RDBMS to your HDFS. Yes, so it's very easy. We have the incremental load. That feature is also provided by Sqoop. What is incremental load actually? You don't want to load the entire table sometimes. Suppose you have a table customers and you just want to load the data of those customers, those who have taken a loan. So you are using an expression which will be having logic that if the person has loan, then only those customers or those employees data you want to load in the HDFS. So it will be known as the incremental load, that we can load the parts of the table whenever it is updated. Suppose the new customer has come and he has taken new loan, so his data has been uploaded into the RDBMS. You are loading it because you just want to focus on the customers who have taken some loan. And suppose a new customer's data is now added into the RDBMS, but he has not taken loan, so you will not upload it to your HDFS. So it is not an incremental load. So that's what the incremental load concept is there actually. When you require some data which has been uploaded into the RDBMS and you need that data based on certain condition, you load it to the HDFS. That is the incremental load. That feature is also provided into the Sqoop. We have the where clause, like SQL, like where clause can be used for that. I'll show it later. Then we have the parallel import and export. Yarn framework you use so the things can be done in parallel way. So not only it will be the import and export is parallel, at the same time it can provide you the fault tolerance. Yes, because HDFS, that HDFS and how Yarn can provide you a fault tolerance using the replication factors. Now you can import results of SQL query. It's a very important thing actually. So some SQL query suppose resulted some particular output. Yes, that output can be queried by using Sqoop commands. That RDBMS output provided by some SQL can be loaded directly to the HDFS. Now we have the compression capacity also. There is a specific parameter available into the Sqoop, that is by -- compress argument we have. By using that we can use particular codec and can compress the data. Yes, we can load a compressed table in Apache Hive also in this way. Now we have the connectors for all major RDBMS databases are available with the Sqoop. So with all major RDBMS like DB2 we have, MySQL we have, then we have Oracle. So all these major RDBMS databases, connectors are already available. Yes, so any connectors you can use to connect with them and get the data uploaded to the HDFS or Hive or HBase. Similarly, you have the Kerberos security available over there. What is the Kerberos security? Is a computer network protocol actually for authentication. It requires ticketing. It provides the ticket from the user to the authentication system. So suppose the ticket is your username and password. Based on that, when the non-secure network is there, in there you can provide your identity and then you will get the login. Yes, because you don't wish that each and everyone will access your RDBMS and get the data to the HDFS, right, and the vice versa. So you'll provide a security mechanism, that is the Kerberos mechanism that is provided by Sqoop. So by using that, I'll show you how you can authenticate a particular user by using username and password and then get into the system only. Now we can load the data directly into Hive or HBase. That's a very nice feature actually. Directly we can load the data to the Hive for data analysis, to the HBase also we can put it inside there. Yes, HiveBase actually. So we can also dump our data into the HBase. The HBase is a NoSQL database. So you go through with the HBase video of mine if you have some doubt on that, because you cannot go through with the Hive and HBase right now. It's not possible to cover these things. Then this video will be very large. So if you don't have any idea about the Hive or HBase, and if you wish to know before you go further, I'll prescribe you to complete this Sqoop tutorial before you go for the Hive and HBase. But if you're really very much having curiosity, then you go with the Hive and HBase videos of mine, watch that and then come back over here. So we'll see with the limitations of the Sqoop. We cannot do each and everything with each and every tools, correct? So we have lots of the limits of Sqoop. First of all, the big thing is that in Sqoop it's not anything we can. It's an atomic job. It is based on the command. So you write a command in Sqoop, press enter for importing or exporting data into our out of the HDFS. You have to just write down the command and press enter. After you press enter, you cannot pause or resume the Apache Sqoop. It will be either working and give you the import or export, or it will be failed. That's it. Yes. Now the performance of this export of from your HDFS to the RDBMS, it depends on the RDBMS server's capacity of its hardware. So that's the limitation we have. So Sqoop on the same time, it's a bit slow because the Sqoop commands will be converted internally to the MapReduce paradigm and into the many mappers, so that will take some time. So in this way, it's very easy to import and export, but it's a bit slow. Yes, and we need spatial handling for failure in importing and exporting data. These are the limits of Apache Sqoop. Now, how it works basically, how Sqoop works. First, we can explain it into the few steps. In the first step, Sqoop will send the request to RDBMS to send the metadata information, because first without metadata means the data about the data. Yes, first you will get the metadata. Next is that when you get the metadata, it will generate Java classes. Yes, so without installing Java in your system, you cannot use Sqoop. Actually, you should supposed to use Java install first, and then you have to install Hadoop before you work with the Sqoop, because Sqoop commands will be internally converted to MapReduce. So you should supposed to have Hadoop installed also. Yes, because then this metadata will become okay. We are into the step 2. So from the metadata information, we'll generate the Java classes automatically. Okay, respective Java classes will be created. Now Sqoop will make packages. Yes, because the compiled classes are created that will be put into the Java packages. This Java packages will generate table structures. Yes, after it compiles, it will create Java files. So just to imagine in this way that suppose you are generating a class, you are importing a class from RDBMS, the name of the class is employee, okay, and you are going to import it to the HDFS. So when you will connect with the RDBMS, you will get the metadata, that is the details of the table first. From the RDBMS, will provide you the metadata. That is, this table employee is having this what? Properties. These are the columns. Suppose it's having the employee ID, employee name, employee address, employee salary. These 4 columns we have. So you'll get first Sqoop will get this metadata from the RDBMS. After you got the metadata, it will generate the Java class for this particular class. So one employee class will be created, and for that employee class will be having these features: employee ID, employee name, employee address, and employee salary. Yes. Now for each line, it will create one separate, it's an internal thing actually. It will create, it will create objects, and all this Java related things will be happening inside, and it will create a package for all the compiled classes. Suppose there are many classes available, many tables available. Suppose employee class is provided by employee class dot class file, that is a byte code in Java. Similarly, it might be many other tables into the database. Suppose you are importing the entire database, so there might be a huge chance that for each and every tables, one separate and independent Java dot class files will be created, and there should be some extra class files to make interconnectivity between them. Yes, so these things are internally done by whom? By the Sqoop itself. So you no need to write down Java code for that. You'll just execute a Sqoop command. That's it. Now how will start with the Sqoop? Let's just see that how actually basically now we are starting with the Sqoop, means we are seeing that how the command will look like. So it looks like this. It's a very simple thing. You have to start typing with the Sqoop to tell the CLI that you are going to write a Sqoop command. Then you have to write down the tool. The tool might be like import and export. On that, property arguments. Property arguments is that where the import and output may happen. That also we can specify as the property argument. And then we have the Sqoop argument. Sqoop specific arguments. And then if you require extra arguments, then also you can provide. So this tool can be a import or export. Yes, property arguments can be Java properties. We provide in the format of dash dname is equals to value. Now Sqoop arguments will be the Sqoop specific things. I'll give an example with that, it will be clear to you. And extra arguments are specialized connectors. Yes, we provide double dash for that. It's very much useful actually, double dash. See this example here. We are writing Sqoop. This percentage sign is to show you that in the CLI we are writing. Okay, that's it. This percentage sign is having no other significance. It's having no other significance. Now we are writing what? We are writing Sqoop. We are writing Sqoop. Then import. So we are going to import something. Import and export means import to HDFS. Export means export from HDFS. So import and export with respect to HDFS we are using the term. After import, what you are writing here? After import, we are writing connect. So what we are doing basically, we are going to connect. Connect with whom? Are you clear? Yes. So this is arguments, right? We are passing. These parameters or arguments we are passing. Double dash connect. So we are connecting between whom? Between this JDBC. Through JDBC driver, we are connecting with the MySQL. So we are connecting basically with MySQL server. What is that? It's running in the local host in the Hadoop guide folder. Yes. Yes. What's the table you are going to access? So you are giving this parameter name double dash table. It's mandatory. So these are the Hadoop specific. This is the Sqoop specific double dash table. Now widgets is the table name we have. Widgets is the name of the table which you are going to import. We're going to import from this location this table. The name of the table is widgets. That's why you're writing double dash table. Then dash m means number of mappers. By default 4 mappers will execute. Okay, so you can specify the number of mappers you're going to use. Here you are using a single mapper. There will be no reducer for any Sqoop command, only mappers, because reducers are used only for summarizing the result of mapper, and here we don't need that. So here we'll just execute mapper, and you can select the number of mappers. So some of the available commands we are giving here, you can check it out later. Code gen, create hive table, eval, yes, export, help, import all tables, job, and all these things. Now we'll see that how to import the result of a query from a relational database into HDFS. Results of a query. So we have to execute some query. From this example, you can understand this. The result of the query to be taken from the relational database into HDFS. So let's see that this is the entire command. Okay, we have given into the next line to make it simple. You can write down in a single line also the same command. So what is the command? Sqoop import. So you are importing something. So we are writing the query. We are telling the CLI of Sqoop, that is command line interface of Sqoop, that we are going to write down some SQL query, and from that SQL query we'll do something. So how we are specifying it? By using double dash query. Double dash query. Then what's the query? It is select ID and message from test table where conditions, there is no condition. Even if there is no conditions, then also you have to write down this $sign conditions. Now we are passing the condition. How we are passing the condition? We are telling the CLI that we are passing condition. How? By double dash where ID is equals to greater than 100. So ID should be greater than 100. That's the condition you are putting. So this is also Sqoop specific $conditions. Yes. So these are all specific things. Now we are writing double dash connect. So what you are connecting? Connecting with this SQL server by using the JDBC driver, Java Database Connectivity Driver, SQL server, which is there in this particular location, in this particular IP address 192.168.1.100 with the port number 1433, and the name of the database is test_db. So this table, test table, lies inside the database test_db. What is this username? Now we are making the connectivity. See, we are authorizing the data, because if you don't know the username and password, you should not supposed to get into the any other database and get the tables from there, or update the execute any query and get the result of the query from there, right? So you're writing this username, double dash username. So now you're telling the CLI of Sqoop that you are going to provide some username. So if the username and double dash password, and we are giving the password, if the user and the password is correct, then only we can make the authentication. Now double dash split by ID. Yes, it specifies the column for the split operation. It is used to split the task to import MapReduce jobs. So split by ID, we are splitting by ID, na? ID should be greater than 100, right? And target directory, we are also specifying by using double dash target directory, target dash dir. What is the directory? Root user test. So this is the HDFS target directory. We are importing, right? Importing means importing to HDFS, not importing to RDBMS. Importing to HDFS. So this is the HDFS directory. Root of the HDFS, then user, then test. Fields terminated by. So when you are getting the data from here, now we are getting some data, right? From the table, it may be generated based on the tabs. So that we are making double dash fields, then dash terminated dash by. So this will mean to CLI of the Sqoop is that whenever we're getting the data from the table, we are getting the query result, like select ID message from test table where ID is equals to 100. Yes, so whenever this thing is executed based on the tab, we are separating the terms and we are storing into the HDFS. So in the HDFS file, there will be one tab. Tab means 8 space, right? So that much space will be there between ID and message. From the value of the ID and value of message, that much difference will be there. That much space will be there in the HDFS file where it will be imported. Now we are importing data directly into Hive data into the Hive warehouse. So I'll not give much focus on it. Last example I have given you entered explanation. You just want to check it out once. So we are also using a Sqoop import, and we are specifying here specifically Hive import. Check it out. The table you are writing, which table? Event log. Where it is, how to connect in the SQL server in this particular ID. Database is also same, test_db. Username and password you are giving, you are splitting by ID and fields terminated by /t. Yes, so directly you are importing to Hive import into this particular table, event log. Yes. Yes, this particular table is now imported, event log. Now you see the same thing by using HBase. It will be used to import the data from RDBMS into the HBase table. If the table does not exist in HBase, it will create a new table, see, and import the data into the table. How you are doing it? Select, see, this query we are executing, Sqoop import double dash query, that is the query you are writing, the same query you are writing. Yes, here we are not providing anything. See here we are not providing any query actually, but just simply you have to write down conditions. It's mandatory. So we are connecting with this particular IP address through JDBC and SQL server, JDBC driver, and we are connecting with the SQL server, which is running in this particular IP address in this particular port number, and the name of the database is test_db with this username and password. username and password you are going to access. Yes, now we're writing double dash hbase dash create dot table. So what it will make? It will make that if the table is not existing over there into the hbase, then this particular table will be created. Yes, hbase dash table. What's the table? It is employee underscore table. So that is the name of the table. Yes. Yes, what is the hbase row key? Means what is the primary key over there? It will be employee ID. So this employee ID which you are fetching now by using this particular SQL query, that will be as a primary key into the employee underscore table. Yes, this table named employee underscore table will be created if it is not available, and there employee underscore ID will be the primary key. That's the concept here. Now we'll see with the import a bit more. So we'll give another example here. What we are doing it here, we are going to import the we are showing you that this particular MySQL query. Select all from countries, limit 10. So 10 countries details will be there. What's that? ID, name and code we have. So this data we just want to import. Yes, how will import that? Is Sqoop import, then these slashes are given so that we can go to the next line. Actually you can ignore this thing, backslash. This backslash you can ignore. We are connecting using the JDBC and MySQL localhost. It's running in the localhost with the user DB. Username is root. Yes, there is no password over here. So just username is provided. There is no password in between the RDBMS and the user. So we are giving the username as root. That's enough. Yes, and the table name. What's the name of the table? Double dash table. We are telling the Sqoop that Sqoop CLI that we are going to use this table. This table, what's the name of the table? Countries. So you are writing over here countries. Double dash m. Double dash specify for what? I showed you before. I told you before. It's for mapper. So number of mapper should be 1. What is the target directory? Root and query result. So this is the HDFS target directory. In this target directory, we are going to load this data. Yes, 1 Afghanistan and AF, then 2 Albania, AL, 3 Algeria, DZ, and so on. Top 10 details from the countries table. Now we'll see how you use the where clause. Just before we show actually a where clause logically. So here also you'll see that how to use the where clause here. So MySQL select all from country from this table, city by country, limit 10. The top 10 data we got. It has this particular field name, city, country name, latitude, longitude and state, correct? And it is describing the city by country. So this is the description of the table. It means that these are the fields are there. These are the types we have. Is it null having or not? Yes, this is true and null. Yes, this is the key. Which is the key? City is the key. Okay, and key means primary key, and the default and all these details they are giving. Now to import, check it out. One particular condition you are giving. What is that? Sqoop import double dash connect. We are connecting with this particular JDBC driver and MySQL. It's running in the local host and it is having the name training inside. Username is training. Yeah, dash p and double dash table. Which table you are going to load? City by country. The last table named as city by country. See, city by country. From city by country, we are targeting directory is root user then where clause. In this particular directory of HDFS, we are going to load the data, and then you are providing this condition. See, by using the double dash where. So you're giving this condition. So last time we show that how where clause can be given inside the SQL query, right? Here we are seeing that how where can be used in different way than the last one. How you are using here? You are providing a particular condition directly while loading. State should be equals to Alaska, and we are using a single mapper for that. So state should be equals to Alaska. So if the city by country, when you are getting the data here, it should be only Alaska. If there is no Alaska, then we will not going to load it. See, now if you go to the directory, you will get these things. How many mappers are there? A single mappers are there. So one part M file will be there, because we are having a single mapper. We specified a single mapper. Na? If you don't provide that, then by default 4 mappers will run for each command, and 4 part file will be created. So if you double click over here and open that this part file, then we can see that the data has been loaded from the table, and only the data which is having Alaska as the state that has been selected. So this is the part of the table. Okay, this limit 10 we have shown just to display over here. There is a big table actually, and there are many details of city by country details are there. Yes, I mean all the Alaskas are only selected, other things are skipped because we are just using this filtering while loading the data. Now we'll see about the export, how exports can be done here. Export is also very simple. It is, you can see that we are come directly to this particular command. We are seeing that Sqoop export we are doing now, connecting with this particular local host and with this username, and the table is exported. The name of the table is exported. Yes, exported table will be first created into the MySQL, otherwise it will not work, because you are going to export this table now from HDFS data you are taking, and HDFS data will be loaded in this particular table exported. So that table has to be created into the MySQL, into the, as you are using MySQL over here, if you use DB2 over here, then in the DB2 that table should be created with the proper column name and type name, everything, because the data should be fitted over there, should fit after coming from the HDFS to RDBMS, the data should get a proper repository to hold on over there. So what we are giving, export directory. What is the export directory? User, then country underscore imported. So from this HDFS, this is the HDFS directory, root of the HDFS, then inside their user is there, then country underscore imported is a directory. Inside there we have a part file in HDFS. This part file's data will be loaded to this particular file, exported, name as the exported. This particular class, the name of the class is what? This particular table, the name of the table is exported. So in this particular table name exported, which is there into the MySQL database, the data of this part file will be loaded. This is how the the SQL export works. Yes, that's it. That's the basics, and very much comprehensive, yet covering the basic, all of the features of Sqoop has been tried to given you. I've tried to given all the details over here, the basic details. So if you have any doubt, you can put into the chat box. You can put into the our comment section. There's a chat box between, you can chat over there. Okay, so if you like these videos, if you think that it's adding the value in your life, in your learning, then please like my videos. Thank you very much.